How is everyone? Are you doing well?
We're doing well. Thank you for
Cool.
asking.
My name is Jason Lindsey with Hooked on Science and STEMfinity. I do a lot of training with STEMfinity across the United States, and we just wanted to show you some pretty cool hands-on science stuff. I'm getting ready to move behind a lab table to blow up a few things and to show you how to use everyday ingredients from around the house to do just that. But I first wanted to introduce you to just a few resources that you can use during this unique time. You know, COVID-19 has kind of forced many parents and even educators to do something very unique, and that is teach virtually. Not every single learner out there, every single student is a virtual learner. So it's kind of new for everyone, not just the teacher, not just the parent, and not just the student. And we wanted to show you some of the amazing resources we have at STEMfinity, as well as Hooked on Science, that will help you through this unique time that I don't think is going to end anytime soon. I think part of this virtual learning is going to continue beyond COVID-19. So I wanted to show you some of those quick websites. Then we're going to do a few experiments. One you can go to is called hookedonscience.org. When you're at hookedonscience.org, you're going to get a free experiment of the week. That includes a video as well as an experiment guide. This is done weekly. You can sign up for the eScience newsletter, follow us on Hooked on Science on Facebook and Instagram. There's always a new, unique, free resource. And just for everybody on here, after this, later on this afternoon, I'm going to upload to this website at the very top something called my at-home science guide. It's free, downloaded. It includes tips on how to engage students during this unique time, and it also includes several experiments for you to try. My friend Bill at STEMfinity has an amazing website. It's your one-stop resource for all STEM materials. He's went out across the United States, the world in some cases, to look for some of the most amazing STEM resources, and you'll find them all right here at the STEMfinity website, stemfinity.com. A little bit later, at the very end, I'm going to introduce you to something called STEM Learning at Home from STEMfinity and take you there. Don't forget, you can also get STEM grant information as well as STEM resources there at stemfinity.com. So that's a quick little introduction to that. Do you have any questions so far before we start blowing up things with items from around the house? None whatsoever. Cool. Okay, I'm going to step behind the lab table here to do some of those pretty cool science experiments. The goal when it comes to home educating, if you will, or to do virtual learning, number one is keep it simple. Use ingredients from around the house, because most kids aren't going to be able to go get the unique ingredients that you might need to do certain experiments. So keep it simple. Make sure you help them understand that when doing science at home or anywhere really, it's okay if it doesn't always work the first time. Actually, I encourage that it doesn't, even with a scientist who does this all the time. Just keep doing it over and over again until you get the result that you want or that you are trying to get at the very end. But it's okay if it doesn't work. It's not the end of the world. And parents, you do not have to be a rocket scientist to do amazing science at home. It's important that you help those parents, teachers, and those after-school learners understand just that you don't have to have a degree in science to help your kid get excited about science. Kids are naturally inquisitive. They're always going to be asking questions. They're always going to be making messes. And parents, teachers, whomever's working with kids understand that messes are okay. And just train them to clean it up afterwards, to clean up after themselves. I can tell you amounts of times that we have created big messes at our house. Holes in the wall from potato launchers, painting the ceiling because we exploded a cloud and it ruined the ceiling. But we're always making messes, but we're always cleaning up after ourselves. Okay, I'm going to step behind the science lab desk and kind of show you one of my favorite science experiments that I like to do, and it's called the balloon blow up. You'll notice in front of me right here, I have a giant jug that has some vinegar in the bottom of it, and then in a punch balloon, and you can get those punch balloons at your local department store. They're there all the time in the party aisle. I filled it up with baking soda. So there's our household ingredients. A jug that you can find. Doesn't have to be this big. It could be a 2-liter bottle. It could be a smaller soda bottle or a Gatorade bottle or a water bottle. I just like to do things on a big scale overall. So inside of here we have the baking soda, something you might have in the cabinet, a balloon, something you can easily get, vinegar, and a jug. This teaches a lot about matter, and kids across America are learning about matter in the 2nd grade and the 5th grade. They learn that matter is anything that takes up space and has mass, that it can exist in 3 main states. I know there's 5, but there's 3 main ones in elementary school that we focus on. So there's a liquid in the bottom of my container, that's the vinegar. The solid would be the balloon, the container, and the baking soda. But we're going to mix together 2 ingredients that's going to create a gas. We'll have a gassy balloon. So let's mix those ingredients together right now. You'll notice they're falling into the bottle, and then a chemical reaction happens, meaning I'm getting something brand new, and that something new is a gas, and it's filling up my balloon. And it will keep going and keep going. Every once in a while, depending on the amount of vinegar and the baking soda, notice I'm not giving you exact amounts because I would prefer for the kid to explore with different amounts many different times. I don't always want to give them the exact thing and kind of hold them to that. I want them to explore and try it different ways. What if we put more baking soda this time versus less, more vinegar, less vinegar? What are the results? Talk about it. One of the big things with next generation science standards and matter is describing what you see. Describe the matter. What does it smell like if it's safe to smell it? Of course, we don't taste in science class. What does it sound like? I hear fizzing. I hear bubbling. Is it hot? Is it cold? And it's a cold reaction. We call that an endothermic reaction. But there we go. We blew up a balloon, not with my smelly breath, but with vinegar and baking soda. A pretty cool science experiment that you can do in many different ways. I'm going to go ahead and set this one down here and grab our next one because this is one of my most favorite and one of the most downloaded science experiments and watched videos at hookedonscience.org. This is one that Kellee Clarkson did with me on the Today Show whenever we made that appearance a couple years ago. She really liked it as well. So here's what I've done. You'll notice that I have what looks like a piece of a water bottle, and that's what it is. So I chopped off half of my water bottle, and on the very end, what I did was I placed a wash rag and attached that wash rag with a rubber band, okay? And here I just have dish soap, something that you find in the kitchen, and water. Now I oversaturated the water with dish soap. Just put a bunch in there. That's a tongue twister. Dish soap. There we go. Same thing here, ingredients from around the house. What I'm going to do next is take the end, the yellow end here, and dip it in here. And then I'm going to blow through this. More about matter. So we can describe the liquid here. We can use a gas from our breath, for example, our mouth, to create our bubble snake. And that's what this experiment is called. So I'm going to blow through the opening where I might drink the water. And you can see my bubble snake. And you can keep doing this forever. I mean, outside's a good place to do. Oh, no. Hopefully my bubble snake won't bite me. But you can change the color of the bubble snake by adding different kinds of food coloring colors. Red, blue, whatever you want to make. Mix some colors. Talk about color mixing, so on. A pretty cool experiment that we can do some amazing stuff with and help kids better understand matter. It looks like it's about a quarter till. I want to go ahead and keep moving with my science experiments. I don't want to overdo my time here with you. I want to make sure everybody else gets in there as well and make sure we get to everything. But bottom line, that's a cool one there. I'm going to rake off my bubble snake, again, making a mess. It's okay to do just that. It's okay to get a little dirty when it comes to science. It's not going to kill you. Well, I say that. Just make sure you do it safely. What else do I have under here that I think you're going to like? Here's another one. I have a balloon, 2 of them. You only need 1. And a very sharp object. It might cut my finger. An orange. You're like, what? This guy's crazy. Oranges aren't sharp. Well, if you're a balloon, an orange is sharp. Here's my question to you. I'm going to challenge you. How in the world do I pop a balloon? Let's go ahead and blow it up. With an orange. So if you're going to do this, and I'll give you a few tips. If you were the students, I would make you explore this. But since we're all working with students at some point in the future, the balloon has to almost pop, okay? It has to almost pop. Big enough? Notice how it went from opaque, I couldn't see through it, to translucent, everything is red. Again, we start learning about those two important words, plus one more, transparent, translucent, opaque, when we introduce light in the first grade and we master it by fourth grade. Okay, I'm going to tie a knot. That's a gigantic balloon. Okay, just like that. Overfill. How do I pop this with this? I could throw it at it. Good hypothesis, but what if I miss and knock over my computer or someone in the head? Not a good idea, right? Good idea. I could create friction, right? Oh, I forgot to tell you though, the two can't touch. You cannot touch the orange to the balloon and the balloon to the orange. Challenging, right? Welcome to being in the real world. Sometimes we encounter a lot of challenging things and we have to problem solve to figure it out. Oh, you're telling me that science helps me problem solve in the real world? Yes, it does. Those skills are important for science and the real world. Okay, what I'm going to do just to speed us up since we don't have a lot of time, I'm going to skip to the point of you exploring and just peel off a piece of my orange, the peeling. So the peeling, there's an orange side and there's a white side, right? I'm going to use the orange side and squeeze the oil onto the balloon. This balloon, second graders, fifth graders learn that the balloon is made of small pieces. The smallest unit of matter is an atom. You put together atoms, you get molecules, so on. We want to take apart those smaller pieces. Well, let's connect it to kids. When kids are learning, they play a lot with Legos, right? Well, your Lego structure contains small pieces, Lego pieces. So this is your Lego structure. This is your little brother or sister that comes into the room after you have worked on your Lego structure for so long, and it pops. Wow. So the orange oil, the oil in the peeling takes apart the smaller pieces that make up the balloon. And then the balloon pops. The bigger the balloon, the better it is, the fresher the orange. Ow, cut me, right? Joking. The fresher the orange, the quicker it's going to pop. Typically what I do with kids is we measure the circumference of the balloon, do a big one, a small one, a medium one, and then we squeeze the orange oil on there. In time, collect data, we can graph it. So that would be the older kids versus the younger kids. Also, what about if I use a lemon, a lime, a grapefruit, all part of the citrus family? Will it work? Good question. Another way you can take this to the next level with students. Okay, we've really talked about matter. Let me get this off the table here. And I want to get to one that has to do with force and motion as we are getting close to about 12:50. And that has to do with a glass of water right here, a toilet paper tube. Maybe hard to find these with our COVID crisis, right? And the big shortage in toilet paper, or maybe we have a lot of them because of that now. A pie pan. I got a strong one, and a raw egg. Okay, so I've got all these ingredients. A force, a push, or a pull. So who's talking about forces? What grades? Typically kindergarten and third grade with next generation science standards. They learned that some things are harder to push than others. It takes more of a push or a pull. When you get to that upper elementary level, you really start to talk about laws of motion. So more force, more mass. That would be the second law of motion. Bottom line, force equals mass times acceleration. So here's how I'm going to set up everything. More simple ingredients. Glass of water, doesn't have to be this fancy glass, doesn't have to be, I say this height. I would let you experiment with different heights of glasses overall. Pie pan on top. Okay, toilet paper tube on top of that. An egg on top of that. Okay, I think I got everything set up here. The goal, the challenge here is, I better move my phone in case if I spill stuff everywhere. The goal, the challenge is to get the egg in the water without spilling everything. And by the way, you can't touch the egg. You can't touch the egg, anything other than the pie pan. Here's a key. We did this on the Today Show not too long ago, but we did a giant tray, 5 glasses of water, 5 toilet paper tubes, and 5 eggs. Same concept, should work. Should, if you do the science right. As soon as you're going to whack the pie pan. As soon as you feel your hand hit the pie pan, you got to stop. Because if you keep going, everything's going to fall over. I've had that happen before on live TV. Okay, so there's another force acting on this too, along with air pushing on it, atmospheric pressure. Gravity. Gravity is pulling everything down. So I'm going to hit this, apply a force. That should go that direction. That should go that direction. Gravity should pull the egg into the cup. Little kids, kindergartners, I've learned you got to hold the cup because they don't always get it right the first time because they're still learning. And that's okay. But if you don't want a big mess all over the floor, just hold the cup at the bottom. 3, 2, and 1. And the egg goes in. All about inertia again, the tendency of an object to resist change. Probably wouldn't introduce inertia to a kindergartner, or you might. I mean, there are some GT kids out there that are reading books at kindergarten and learning about inertia. But I will keep it simple, and that is apply a force, a push or a pull. Those two items went one way. Gravity pulled the egg in. Voila, we have the egg in the water. Cool experiment. Pretty cool experiment. I call it the egg drop. And you can already find that experiment at the website, hookedonscience.org. There's a guide and a video. Let me make sure. Let's see if we have enough time for me to do one more. It's 12:51. Yeah, we got plenty of time. What else do I have under here? I think you might like this one. I have a bag full of toilet water. No, not toilet water. Vinegar again. Then over here, I have a napkin. Hiding inside of my napkin, I have placed baking soda. Wow, big surprise, right? So what I'm going to do is wrap this up like a present, maybe a present you don't want, but for the science experiment, we need to make it work. See how I did that? Basically, baking soda inside a paper towel. Now I'm going to place that inside of here. Does your sandwich bag explode? Probably not, right? Unless you replace the sandwich with vinegar and baking soda. We did that off the top, if you remember. And if you remember, we talked about a chemical reaction versus a physical reaction. We didn't elaborate on it, but we will now. Physical reaction basically is me peeling the orange. It's still an orange whether I peel it or not. But a chemical reaction, when I mix two ingredients together, I get something new. In this case, I'm going to get more gas like we did in the beginning, and the sandwich bag should explode. Make sure it's zipped. Okay, I have computers everywhere, so let me make sure I don't create a disaster here. I'm mixing it up. Oh. And there we go. Another big mess. This thing's still going. We might be able to get it to go again. But that's okay. And I smell like vinegar. My new cologne, right? Okay with me. Pretty cool science experiment that you can do. And it makes a big mess. You know, you could put different color vinegar in there by changing it with food coloring, so on, all that good stuff. Just mix it up, make it more fun with kids, so on. They love that kind of stuff. What else do I have under here that I think you're going to like? Oh, I like this one right here. This here is a skewer. Again, all this stuff you can get from around the house. This skewer you can get from your camping aisle at your department store. And then another punch balloon. I'm going to fill this up with my breath. Now, I say fill it up as I taste vinegar, by the way. Just make sure kids are doing safe science. Vinegar's not going to kill them, but you don't want them to drink gallons of it. Okay, filling it up full of air. You think that's enough? What do you think? Yes? No? Bigger? Bigger? Okay. How about that? Let's go bigger. Okay, I think that's enough. I'm going to tie it. My hands are a little slippery. We see how successfully I can do this. Okay, balloon. Filled full of air, a gas. The balloon itself is a solid. We know the balloon is made up of small pieces. Okay. Sharp objects, balloons, don't go well together, right? So here's the challenge. And I always try to make it a challenge, especially for the older kids, because they kind of like that challenge. They turn it into a game and, you know, I bet you I can do it. Oh, I can do it better, or whatever it might be. How in the world can you skewer a balloon without popping it? Well, let's investigate the balloon. It's shiny, okay? It's shaped more like my head, an oval, so three-dimensionally, that's an ovoid, geometrically speaking. I can put my head on it. Oh, it says fifth graders smell like cheese. I wonder if that's true or not. And you'll notice that it's shiny here, dull down here. The opposite of shiny is dull, the opposite of day is night. I'm going to go down there because that's where the smaller pieces that make up the balloon or holding hands just right. This will be our last experiment. Then we'll spend the last 5 minutes asking questions overall. Okay, I'm going through the bottom. Oh no. The balloon, I can't see through it, so it's opaque, opaque, opaque. Gonna go to the top. My hands are still slippery from vinegar. Let's see if we can make this work without it popping. Cross your fingers, pick your nose. Okay, joking obviously. And we did it. Yes, we were able to make this thing skewer just right. Perfect. I'm gonna come back over here and sit down and chat with you, show it to you just a little bit closer. You'll notice there how we were able to skewer that. Why? Because the smaller pieces of matter are linking up around the skewer. What's going to happen when I remove the skewer? Hypothesis: doesn't pop. Why? Those smaller pieces of matter, with a super small hole, we're able to link back up, and then it doesn't go flat just yet. It will eventually go where it's shiny. You enjoyed those, did you? Do you have any questions? I'm looking here. I'm getting a little bit closer. Let's see. I'm not seeing any questions. I can't hear anybody. I want to make sure that my audio's on and all that good stuff.
Jason, can you see the chat box? Can you see the chat box? If anyone has any questions, if you want to write them in the chat for Jason. Jason, I have a question.
Yes, ma'am.
So what inspired you for the lab coat / bow tie combo?
You know, for the longest time, I'm a scientist. I'm a television meteorologist. So when I'm not visiting hundreds of schools across America, I am in classrooms doing the science or on TV doing weather. So I do that part-time now. I used to do it full-time. So what I would see when I would go into schools, because a lot of people would ask for a meteorologist to come in, is that the hands-on factor wasn't there. So I'm like, you know what? I've got to develop something to where kids are going to get exposed to hands-on science. So that was back in 2007 when I started that. And this all kind of evolved or kind of went with it. The lab coat, the bow tie. It's all about creating the character, if you will, that people can remember. So it's a marketing thing, but still, I wear lab coats all day long, right?
Yeah. Well, it's definitely a great look. We do have one question from Elaine. So she says, can you try doing the balloon pop with a regular balloon?
The balloon pop, are you talking about the skewering it or popping it with an orange?
Elaine, can you clarify?
You can unmic. Skewering the last project that you did.
Yeah, you can. You just have to be a little more patient. I find that the bigger balloons work best, but if you're going to do a smaller regular balloon, I suggest you don't blow it up all the way, because if it's really tight and you've stretched those smaller pieces that are linked up, it's going to be easier to pop. So I wouldn't fill it up as big if you're going to use a smaller balloon.
Thank you.
But it will work with the smaller skewer too.
Awesome. Thank you.
Yeah, you're welcome. Any other questions before I quickly show you a few more things?
Go for it, Jason. I'll moderate the chat, and then I'll let you know if anyone has questions.
Awesome. hookedonscience.org. Don't forget, I will put in the next hour or so check back this evening. At the top of it, you will actually see next to Science on the Go, or somewhere within that, probably in the new section there, free at-home science guide. It includes my tips on getting kids excited about science at home, how to do that efficiently, and free experiments, coloring sheets, so on, depending on what grade you work with. STEMfinity.com. Don't forget to go check that out. Once you click on STEAM Learning at Home, this is going to pop up. It has all kinds of important things. You can get STEM products under $100 there. You can shop by topics for STEM, technology, engineering, art, math, and robotics. So you got your STEM, your STEAM, and your STREAM going on there. But Bill has strategically put that at the very top. So go ahead and click on that, and it's going to talk more about STEM, STEAM, STREAM learning at home. Not to mention there are tons of resources there, bottom line, when it comes to STEM stuff. So go check all of that out. Sign up for Bill's e-newsletter. Sign up for mine at both of the websites. Don't forget to go like us on Facebook, Instagram. I don't have Twitter, but I know Bill does. So be sure to like us on all the social media platforms as well.